Our topic for today is scientific inquiry. Now, in a previous science class, you may have actually learned the scientific method. And the scientific method is a model similar to what we talked about the last time for how the scientific process works. It's actually a little bit incomplete, and that's why your textbook uses scientific inquiry instead. Now, what I am going to ask you to do is to be able to put the steps of scientific inquiry into the correct order. So you might plan ahead for that as I'm going through some of this today so that you can figure out how you're going to do that. And I will give you a memory tip to do that as well. So there are 8 steps in scientific inquiry. And you may think that this is something that you would never do unless you're in science class, but actually this is something that you do all of the time. So it starts out with observation. And observation, while students generally think observation means it's something that I have to see, an observation can be something that I hear. For example, if I hear a crash in the kitchen, and I know that my grandkids are downstairs, I might go to check to make sure that one of them isn't trying to climb on top of the refrigerator to get the cookie jar because I heard something. Okay, so that would be an observation. Even though I didn't see it, I heard it. It may be that I noticed that my desktop is wet. Why is my desktop wet? And I might investigate that. Okay, it's because the window's open and it's raining. Okay, so observations are things that you not only see, but hear, you touch, you experience in another way. An observation can be done with some sort of equipment, like with binoculars or a microscope or maybe a scale. And so if I step on the scale, I can observe how much weight I've gained after I've eaten way too many Christmas cookies. Okay, so observation, things that I observe going on around me. This observation is the absolute main part, the central part of scientific inquiry, because if you don't have observation, you can't do any of the rest of it. So this is the most important part because you're going to be observing as you go all the way through this process. Okay, so the next thing you're going to do is you're going to pose a question. Okay, I heard a crash in the kitchen. What made that crash happen? Why did that happen? I noticed that my desk is wet. Why is my desk wet? I noticed something and I ask a question as to what caused it. Okay, remember we talked about cause and effect. What caused that to happen? Okay, why did this come about? So I'm looking for a cause for what I just observed. I'm going to do some research. I'm going to go see if I can figure out what happened in order to make this observation. So in the case of the crash in the kitchen, I'm going to go downstairs and I'm going to check and see exactly what it was that fell. Was it the cookie jar? Was it my grandson? Was it something that fell off someplace else because something blew, and maybe something blew off the counter because the window's open? Okay, so I'm going to do some research. I'm going to try to figure out exactly what happened. Then I'm going to form a hypothesis. Well, I noticed that my desk is wet and it is raining outside, so my hypothesis is that the rain is coming in the open window. Okay, I noticed that the cookie jar is broken on the floor, and I noticed that my grandson is nowhere to be found, but all the cookies that were there have now disappeared. My hypothesis is that he knocked the cookie jar off, took the cookies and disappeared into the closet, and he's now eating them. Okay, that's a hypothesis. I do the hypothesis, make the hypothesis. I'm making some sort of a guess. It can be a guess. It can be I might be pretty sure about that may be what happened. But it's something that I can either prove or I can disprove. And so then I'm going to do some sort of an investigation to figure out if my hypothesis is right. Now, from a scientific perspective, this investigation most often will involve an experiment. Now, if we're talking about something around the house, that may not be true. So the investigation may be in the part of the crash I heard in the kitchen. I may go open up the closet, see if my grandson is sitting in there with cookies or not, to see if that's actually what happened. Did he knock the cookie jar off, take the cookies, and go eat them? If I do an experiment to see why my desk is wet and I notice it's raining, maybe my experiment is that I'm going to close the window, I'm going to dry off the desk, and see if it gets wet again. Okay, that would be my experiment there. Okay, so then once I've conducted the investigation, then I'm going to do an analysis on what happened. Okay, the analysis is, yep, sure enough, there's my grandson. He has chocolate chips smeared all over his face, and he's surrounded by a pile of cookie crumbs. I would say that my analysis is that he did knock the cookie jar off and steal the cookies. With my desk, perhaps it's okay that my desk is no longer getting wet, and so my analysis is that the rain was indeed coming in the window. So I'm then going to form a conclusion. My conclusion is that if it's raining, I need to keep the window closed. With my grandson, my conclusion perhaps is that maybe I should ask him if he's hungry in place of just going off and leaving him, or maybe I should check and see that I have put the cookie jar truly out of reach so that he can't get to it and end up hurting himself and ruining his dinner in the process. Okay, so that's the conclusion that I reach. And then a lot of times you're going to have to communicate that. So I may also tell my husband the cookie jar is not in the same place it usually is because our grandson is here and he'll knock it over. So I've moved it to this location so that he can't get to it. Okay. I may tell all the other people in the house, hey, it's raining, close the windows so that your desks, your computers, your phones, whatever, don't get wet. So you're going to communicate what you have learned. In the case of science, this is often, if I could spell that correctly, it would help. This is often communicated via what's called a peer review. And a peer review just means that as a scientist, if I have done some kind of an experiment, then I am going to then take that to fellow scientists and say, I've done this experiment. Can you verify this? Can you repeat the experiment? Can you do a similar experiment to make sure that I'm right and that this wasn't some sort of a fluke or that I haven't misanalyzed something? And so it's really important in the scientific world for scientists to communicate with each other and make sure that they're all getting to the same truth, the same conclusion when they do experiments. Let me give you one more example here of how this process works. My husband knows that my absolute favorite type of flower is a petunia. And so several years ago, he bought some petunias and he put them in some hanging baskets and put them outside of our deck. And after several years, now petunias are something that have to be replanted every year. They're called an annual, and so they have to be replanted every year. And so he kept using the same baskets every year because they were real good baskets. And after several years, he noticed the petunias weren't doing so well anymore. And so that was his initial observation, that the petunias were turning yellow. They didn't look very good. And so that was his observation. So then his question is, these were doing really well before. Why aren't they doing well now? So that's his question. This has always worked before. Why has it suddenly stopped working? Okay, so what he did is he did some research. He went to the internet to find out if he could find some sort of reason why petunias that had been doing so well before suddenly are not doing well. And what he discovered was that after a number of years, a fungus develops in the soil. And once that fungus develops, then the petunias don't do well anymore. So he formed a hypothesis. He said, I really don't want to throw the baskets away. So maybe if I dump out the potting soil, if I wash and disinfect the baskets and put brand new potting soil in, maybe then I can put petunias back in the baskets. And so that was his hypothesis. Hypotheses are normally an if-then statement. So he says, if I wash and disinfect the baskets and if I put new potting soil in, then I'll be able to grow petunias in those baskets again this year. So that was his investigation. That was his experiment. He dumped all the soil out. He washed the baskets. He disinfected them. He put new soil in and planted new petunias. And so his analysis will come a little bit later in the summer. This is actually an ongoing experiment as I'm telling you this story. His analysis will then later be, yes, this worked. The petunias are doing very well, or no, it didn't work. I'm going to have to come up with something else. So that will be his analysis. If everything works well and the petunias do well this summer, his conclusion will be, all right, then every year I need to make sure that I disinfect the baskets, the hanging baskets, and put new soil in them before I plant new ones. So that would be his conclusion. And then he would likely go tell his dad, who's also having trouble with his petunias, and he'll say, hey, I found this out, I did this worked, why don't you try it and see if it works for you? And so he's then going to communicate that information to someone else. Okay, so how are you going to remember the order of the scientific inquiry? Sometimes what I do, if I have to remember the order of something, I make up another sentence in order to put things in the right order, because it helps me to remember the order better. So I'll give you the sentence I made up. You may not like it. You may want to come up with your own, but here's the sentence that I came up with. So observation starts with an O, so I'm going to use the word O. And I use the Q for questions because I thought that was a better word. So I put the word quit. R in research is running. And then again, I use, instead of forming, I use the word hypotheses because that's really the more important word here. Quit running hurriedly. The I made the word into. The A, I actually just left as an A. And then I had two C's, and I used the word confused, and I used the word cow. And the C-O-N here goes with the C-O-N here, so I can keep my two C's straight. So my sentence that I can remember is, oh, quit running hurriedly into a confused cow. Then I have this picture in my mind that I have a cow standing out in the pasture who's looking very confused, and then I'm running around and I'm in such a hurry that I run into the cow. Okay, yeah, it's kind of silly, but if you can remember that silly sentence, then you may be able to get these words in the correct order. If you don't like my sentence, you can make up your own. If you don't need it, that's okay too. But oh, quit running hurriedly into a confused cow may help you remember observation, questions, research, hypotheses, investigation, analysis, conclusion, and communication. And I will expect you to put those in the correct order on your test, so you want to make sure that you come up with a good way to do it. You may also want to put each of these on an index card and then practice rearranging index cards until you can get those in the right order as well. So that is scientific inquiry.